See this problem. Two trucks heading in opposite directions with speed 60 kmph and 70 kmph respectively approach each other. The driver of the first truck sounds his horn of frequency 400 Hz. What frequency does the driver of the second truck hear? Velocity of sound in air is equal to 330 meter per second. After the two trucks have passed each other, what frequency does the driver of the second truck hear? It is similar to the previous problem. Our motto is, there are two trucks which are approaching each other with some velocities Vs and Vo. This is observer velocity, this is source velocity. The first truck is blowing a horn with frequency n. The person in the second truck hears that the sound wave and detects the frequency as n1. The velocity of the sound in air is v. We need to find out n1 in first case, and in second case those two are moving away, like after crossing they are moving with their own velocities like v0 and vs. But here at the time also he is blowing the horn with frequency n, but the observer is listening with a frequency n2. We need to find out n1 and n2. So that is our motto. Now I am going to investigate the quantities that I have given. So Vs, source velocity is 60 kmph, that is equal to 60 into, I am converting into SI system, so that is 5 by 18, that is equal to 50 by 3 meter per second is the velocity in SI system. And observer is also moving with velocity 70 kmph, that is equal to 70 into 5 by 18, that is equal to 175 by 9 meter per second. Now n is equal to, the frequency of the vessel is equal to 400 Hz and the velocity of sound is equal to 330 meter per second. Those are the given quantities. Now I am going to resolve these things. From the Doppler effect we already know the formula, like n observing is equal to v plus or minus v0 by v plus or minus vs into n. So these plus or minus should be used according to the approach and leaving. So in the first case the two trucks are approaching, so in the first case n1 is equal to v plus v0 divided by v minus vs into n. In the second case n2 is equal to v minus v0 by v plus vs into n. So if you substitute those given values, it is a direct formula, so if you substitute those given values, that is 340 plus 175 by 9 divided by 340 minus 50 by 9, 50 by 3. Actually I will multiply 3 for the numerator, 3 for the denominator, so you will get 150 by 9, because I want to equate the bases, the denominators of the these fractions, which is into 400. And in this case, in n2 case, this is n1, this is n2 case, 340 minus 175 by 9 divided by 340 plus 150 by 9 into 400, that is equal to, I'll get 9 into 340 plus 175 divided by 9 into 340 minus 150 is equal into 400. And here in N2 case also 9 into 340 minus 175 divided by 9 into 340 plus 150 into 400. So N1 is equal to, you will get 2970 plus 175 divided by 2970 minus 150 into 400, and in N2 case it is 2970 minus 175 divided by 2970 plus 150 into 400, that is equal to 31. N1 is equal to 3145 divided by 2820 into 400, and N2 is equal to 2795 divided by 3120 into 400. Now I am going to find the values using calculator. So 3145 into 400 divided by 2820, that is 446.1 hertz. That is, this is the frequency when observed by the observer when it is approaching. Now N2 is equal to, I am using the calculator, 2795 into 400 divided by 3120, that is equal to 358.33. So 358.3 hertz is the frequency observed when they are separating each other.